All right, welcome everyone. Thank you very much for attending the inaugural Americas Trino Meetup. We had EMEA this morning, and as well as APAC in the same group, and that went perfectly fine. And then we had some weird issue with Zoom just now, where I had to basically just let you all come in and hang out in one of my own personal rooms. So welcome to the meetup. This is hosted by Starburst. We basically are building a software around Trino and have a couple solutions as well as support that we offer. And so we're going to be going into a little bit about some of the one of the particular solutions when we have our message from the sponsor, which will be given by one of our product managers, Vishal. If you haven't yet so far, please give us a star on the Trino repository, Trino be Trino, and that will give us a little bit more visibility on GitHub. So agenda today, we're going to kind of introduce the speakers that are going to be talking today. Going to go right into our sponsor message with Vishal, like I just mentioned. I'm going to do a little bit of a Trino overview. We have a lot of exciting announcements coming up. And then we'll jump right into it with the State of Trino with Martine, talking about where we're at, where we're going, and then head straight into a Ask Me Anything session with Martine, Dane, David, and Eric. So get some questions going on in your mind. I mean, feel free to put questions in the chat as we move along throughout the presentation, and we may surface some of those. We may just keep them to the end of the session. And these we call this an AMA because you can ask things even a little bit outside of just specifically Trino. Feel free to just kind of we want to make this more of a social type event near the end. So feel free to ask anything kind of adjacent. So let's talk about the speakers today. You probably know most of those four gentlemen on the top. They are Martine, Dane, and David and Eric, and they are the founders and creators of Presto and now Trino. And so they will be talking about where we are at with the project. Today also we're going to be announcing the launch of the Trino Definitive Guide, which is written by Martine as well as Manfred and Matt Fuller. So Manfred will be introducing that book as well. We have myself, developer advocate at Starburst, and Vishal, who is product at Starburst. He's going to be talking about Galaxy, and actually we will hand over the mic to him. If you want to take over, Vishal, and tell everybody about Starburst Galaxy.
Thank you, Brian. Let me share my screen. Let me know if you all can see my screen.
Yep.
Awesome. So thank you, Brian, for having me here, and thank you, community, for actually having me here. I'm really excited to talk about one of the new offerings, Starburst Galaxy, today, and how you can actually gain the power of Trino within minutes using our new solution, Starburst Galaxy. So, as we all know, and this is actually goes into the foundation of Starburst. Our founders and our founders at Facebook and our founders at Teradata, when they thought about Trino, they actually wanted to solve the problem for the organization, because most organizations have massive amount of data sitting in all the formats like data lakes, warehouses, and etc. And they all needed to put them in a common format, and that required them to move it, copy it, consolidate into on-prem or in cloud. And this is extremely time-consuming, and it's laborious, and it adds zero value, and it increases security risk. Ultimately, what it drives down is to your ability to providing insights at the speed of business, which is where the 80% of enterprise time is spent. As Starburst, we want our customer and our prospects to spend time finding the business answer, and rest be left to us. And that's what led to the birth of Starburst. Starburst used the power of Trino to ensure the single point of access. While serving our customers, Starburst firmly believes in giving back to the community, and this is why Starburst is also the biggest contributor to Trino open source project. At the moment, we have two different offerings. One is manual and one is Kubernetes-based offering. Our Kubernetes-based offering allows our customer to automatically manage their infrastructure with change in your daily workload. The initial setup for the Kubernetes offering takes some time, and the administrator needs to be a little technical to get the Starburst up and running. Something which I found on Twitter, and I found it funny, is that once I tried explaining Kubernetes to someone, and I completely lost what Kubernetes meant. And that's how complex Kubernetes is when you want to get things up and running, when it gets in a state, when it can provide a solution, it's perfect. But there's a steep learning curve to it. What if I told you you don't have to be a Kubernetes expert to gain the power of Trino, and you just can actually leverage the power of Trino without knowing all the infrastructure details go behind it. And that idea led to the birth of Starburst Galaxy. With Starburst Galaxy, we want to help teams of all sizes with all capabilities to unlock the power of Trino for analytics. Let me walk through your key benefits as you see here. Starburst Galaxy helps to eliminate administrative overhead and infrastructure build out with automated provisioning, configuration, upgrades, and patching. It centrally manages security, data privacy, and data protection with authority to comply with your regulations. While you get to query data interactively from all the data sources with our SQL native tool, and also any BI tool which you already use. Galaxy scales up and down with changing your workload, and also give you full cost transparency where you only pay for what you use. And that was the idea behind Galaxy. Let me walk through a quick architecture of what Galaxy is. Sorry, there is a logo. My bad about that. Give me 1 second. So let me walk through the Starburst, the Galaxy architecture. Starburst firmly believes that customers should own their data. Data should never leave the customer's environment. Architecturally, the main components that make up Galaxy are the control plane that provides everything a user needs to access and manage their environment from a single beautiful interface. There's a data plane where the clusters of Trino compute perform operations running in your cloud account. So data is never going to cross your account. And finally, there's an underlying data sources that Galaxy connects to for query processing and push down. So with the larger vision of getting power of Trino in everyone's reach within minutes, we have also worked really hard to create the amazing user experience around it. Ali, who was the force behind the Trino logo, Commander Bun, has put tremendous amounts of UX work and research so that customer can enjoy the experience of Galaxy while gaining the full power of Trino and getting right into details of getting access to your data. We are going GA on AWS in May. Right now, we are in public beta, but GA is coming literally within less than a month with the free trial. I'm reaching out to the community. Go sign up for the Galaxy on the starburst.io, join Galaxy, and realize how you can access Trino within minutes instead of actually trying to learn what Kubernetes or what infrastructure and whatnot goes behind the scene. Leave that to Starburst. Thank you. And as I said, my name is Vishal Singh. Please sign up and let me know if you have any question through the chat and Zoom, and I will be available to answer any questions.
Awesome. Thank you, Vishal, and yeah, anybody just put. You could use the chat basically to ask questions. Since we're not on the webinar, we're just going to use chat for the questions for this. So Vishal will be sticking around, and we'll be around throughout the rest of the meetup today to answer those questions. So yeah, thank you, Vishal, and thanks to Starburst for sponsoring this meetup. So let's get on to a couple cool announcements that we have coming up. So first, I wanted to talk about a little bit of administration from how we're planning to run these meetups moving forward. So basic idea, we really knew that in these times we're getting closer to face-to-face, but we're not quite there yet, and we really still don't have any idea exactly when we're going to be returning. So what we wanted to do is in the interim, we wanted to open up 3 virtual groups that we're going to capture area by time zone. So we have the Americas, we have EMEA, and we have Asia Pacific. So basically, these virtual groups are initially going to be our primary vehicle to host these meetups. But eventually, the idea, what we want to get to when we do have face-to-face again, is we want to start getting back into the local meetups and start trying to find champions and find local Trino fanatics that are interested in running meetups in their town. So that's going to be something that we'll bring up more and more as we get closer to face-to-face. And then what we ideally would do is, eventually these virtual meetups will continue and be a resource for people who are not necessarily close to one of these local meetups when we get back to that. And we would ultimately be trying to kind of take local, basically talks from local meetups and maybe recordings, and then have the speakers from those talks present at the virtual one, and you could basically just see the same talk and then basically follow up with a question and answer. So this is kind of how we're structuring things moving forward, and we definitely want to get feedback into what everybody else is kind of interested in, and how we should be structuring this moving forward as well. Definitely want to get community feedback, but that's how we're seeing it initially. So for anybody who is coming to this meetup that is first time hearing about Trino, I wanted to give a quick rundown of what Trino does in a very high level. So Trino is a distributed SQL query engine. That means that basically it's trying to it's just the engine. It's not going to actually be the database. It's not storing the data. And so what does store the data? Well, it connects to multiple data sources. So you can have anything. Initially, the primary use case was kind of data lakes and Hive or eventually S3. But then this expanded out to be any kind of data connector that could be written in kind of that like basically returns data that can eventually be somehow synthesized into rows and columns, right? So anything from NoSQL type databases like Elasticsearch and Mongo. We even can run queries over Kafka or other type of streaming things like Pinot as well as Druid and real-time type systems like that. So we pull that data, we can join it and basically during a query time, and ultimately return that data to a single worker node, and that ultimately gets returned back to the client. So Trino clients can be anything from JDBC connectors, also ODBC, as well as we have Python clients. There are also community supported clients like Node. And so these are all things that can be used by a wide range of tools, obviously within your programming languages, but also within like very well-known BI tools like Power BI, Looker, Tableau. And so this is ultimately what Trino is doing, is you're able to now do these kind of federated use cases as well as speeding up queries over data lakes to basically enable the analytics that you're trying to run. So in a nutshell, that's more or less what Trino is doing. There are multiple use cases that we've heard from the community that go into further things, but for the most part, when we're trying to kind of understand our location, if you know these maps from Martin Kleppmann's book, you might find us closer to this thing he calls the kingdom of analytics. So he's more or less just trying to kind of split up two segments of the database space, which is, OLTP data, more focused on data integrity, and then OLAP data, which is more focused on analytics over multiple data sources. And so basically, that brings us to what about this? Isn't this the same as Presto? And we have a lot of confusion that in the community from this. And so I wanted to take a quick moment to kind of talk about some of the history in terms of how this unrolled. So Martine, Dan, and David, and Eric all were founded the open source Presto project in Facebook in 2012. Ultimately, Facebook management kind of started putting pressure on the project to kind of give automatic committer privileges and to Facebook members and to Facebook employees, and different types of rules that kind of did not comply with kind of an open source, healthy open source type of healthy open source community. So basically around 2018, right after these changes were made in the way that Presto was going to be managed, the founders quit and they moved on to create the Presto Software Foundation. And immediately after that, everybody in the community followed. And well, we thought that was that, but then Facebook ended up changing that initial decision and moved PrestoDB underneath Linux Foundation. And now it kind of sits there, still existing in open source, but kind of mostly caters to Facebook needs. In 2020, now Linux Foundation then enforced the Presto trademark, and then we were forced at that point to rename to Trino. So the one thing to kind of pull from this is that, when a lot of people get confused because they see that there's this Facebook open source project called Presto, and then there's Trino, and they're not really sure where to go to. One thing to kind of keep in mind is this central thing that Martine kind of mentioned, which was companies don't run open source projects, people do. So it's really important to consider that Trino is where the majority of the people who have written the code that exists in both Presto and Trino, it all exists underneath the Trino house. All of those individuals that have spent late nights and really worked hard on building this community and building what is both, what was Presto and what is now Trino. They now exist underneath the banner of Trino. So that's something to keep in mind when you're kind of trying to understand this history and this lineage of these two complicated things. So we obviously believe that this is where you should be. So congratulations on making the first step in the right direction. So if you want to join our community, there are a lot of things going on. Obviously, we have these meetups. We also have a biweekly community broadcast where we basically just dig into various aspects of, the connectors. We also talk about internals of the core query engine, and so that's co-hosted, by the way, with Manfred. So yeah, we're always looking for kind of suggestions or bringing people onto the show to kind of talk about their particular use cases and kind of finding out what's going on in the community and bringing that to light to everyone else, in maybe ways that aren't natural and kind of like Slack. But in ways that are natural to Slack, you can also join our Trino Slack. And that's where a lot of our discussions go along. Anytime you're wanting a new feature or trying to add a new feature yourself, maybe trying to dig into joining our crew and developing, you can go to our Slack and ask any of the folks there on help on how to do that. And finally, if you want to contribute to either with code or contribute with blogs or contribute with documentation, there are all these resources here. And I've, by the way, I've sent a link to a doc in the chat, probably a little higher up now, feel free to go into that and check out all of these links. You don't have to frantically be taking screenshots or writing this down. And then the final thing before we hop off this is we are officially announcing the Trino Summit that will be taking place this September. So go ahead and go to starburst.io/Trino Summit 2021 to register for Trino, the Trino Summit, and also if you are interested in doing a talk for that, reach out to me on the Slack channel as well if you have something cool to talk about. Okay, and for coming to this meetup, I did want to offer everybody thank you very much for joining, and basically here is the URL also included in that doc that I sent to basically sign up for a Commander Bun Bun t-shirt. We have this style, and we also have another one of Commander Bun Bun in space. I actually don't have it out with me. Does anybody on the here have one of those to show off? Yeah, you have the other one too, Manfred. So anyways, it's another one of Commander Bun Bun.
Here, I got it.
Yeah, there you go. Dane's got it. So that is the other option. We don't have a way to choose. So right now we're doing kind of at random, but don't worry. There will always be other opportunities to get to complete your 2-shirt collection. And so now I'm going to take a pause and let Manfred take over just the speaker part and tell us a little bit about the upgrade on the definitive guide. Manfred?
Yeah, thanks. It's crazy how time flies. It's been just a bit under a year that we launched the book Presto, the Definitive Guide with O'Reilly, got that out. We're very happy. It created a lot of demand and was the first book about Presto that had really good information about things like the web UI, just getting started simpler. And there is a great intro in addition to the official docs that we obviously have as well and maintain as well. Now with the rename, this year we were wanting to make sure that we have the right name on that book as well. So we did rejig the book completely to have the new name, be updated in terms of the version, latest version now with 354 is in the book. So it has a lot of new features, obviously, in that year. There's more content in the book now. And also, obviously, Trino is much more powerful again. And thankfully to Starburst, free copies of the book are available again. Last time when we offered those books for free, over 5,000 people downloaded a book PDF for free, and it's very useful to have. So please take advantage of that again, and you see the URL right there. So that's really good to have. And if you are interested and find the book useful, we would love for you to also help us improve and make the documentation even better. Related to that, we are participating in the Write the Docs conference on the coming Sunday for Writing Day. So whoever is interested in sort of, now getting their feet wet with contributing to an open source project, Sunday is a great day to have a go at that. I'll be online all day and helping people get started on contributing to Trino with, very little fixes on the docs and all the way to a little bit of more of a documentation for a function or more. This is all part of Writing Day for the conference called Write the Docs Portland. It's a virtual conference. But we will also be able to, a lot of this information is in videos as well and in the README. So it's also available on our YouTube channel. So yeah, and we can also find us on Slack anytime. So there's really no problem anymore. And thankfully, Rose also posted the URL now. So thank you very much for that.
I was just gonna say, I was like, we have the URL in the let me go ahead and repost my my.
Rose posted it in the chat already, so we're good.
Right. I'm just saying this document here has a whole bunch of the links that are pertinent to what we're sharing in the email. So I figured I would share that again, just so that everybody can see that one more time. And yeah, check out any of the links that we have up here on the slide, as well as some of the ones that we're talking about are included in that Google Doc that I just shared. So feel free to check that out as well. And thanks for posting that, Rose. All right. Anything else you wanted to cover, Manfred, before you?
Oh, get a copy. That's
all right. Yes, get your free copy. Okay, so with that, let's move this on back to. We're going to hand this over to Martine to share with us the state of the Trino project. So Martine, whenever you can.
Just a second, I just need to unmute. Let me share my screen here. Okay. Can you see the slides?
Yep.
Okay. Right. Thank you, Brian. So today we're going to talk about where we are in the project, how the community is doing, all the recent features that we added to Trino over the past roughly a year or so, and then we're going to touch briefly on some of the work that is going on right now and is likely to land in the next few months or so. Right. Brian kind of covered some of this content that I was going to talk about. But in terms of what is Trino, like the relationship between PrestoDB and Trino, the one thing I wanted to reiterate and drive the point here is that if you have been using Presto, specifically the Presto SQL variant for the past 2 years, if you have been participating in the community, in the Slack channels and so on, you have already been using Trino. It's the same software, the same group of people. The same community, just under a new name, and of course we have a new, very cute bunny as a mascot. So if you want to get more details about like the story around the rename, why we did it, and so on, there's a link to a blog post you can follow. And if you're migrating from an older version of Presto SQL when it was named Presto SQL to Trino, there are some considerations you have to take into account, and there's another blog post linked on the slide that talks about all the things you might want to consider. And I think Eric earlier mentioned there's some issues around ODBC and clients that you have to take into account. Right. Since we renamed the project, like the project has the popularity of the project has gone through the roof, and you can see in this chart, this is the number of stars on the GitHub repo over time since the split back in 2019, and then this is when the project got renamed. So that came, it was very well received by the community. As others were saying, now that we have a different name, it clears up all the confusion, so people can rally behind one project and just keep driving it forward. So if you haven't given us a start, please do so we can make this line go even higher. Over the past, from the beginning of the project, really, we've had more than 460 contributors just to the code base. That doesn't include people that have contributed in terms of writing blog posts, helping other people in the Slack channel with their questions and so on. And this number has been growing steadily. It's reflective of how vibrant and active the community is. This is also reflected in the number of people that have joined Slack since over the past couple of years. We started with 800 people in around January 2019. Now we have more than 4,000 people, and 500 of those are active every week in the channels. So if you're not on Slack, by all means join. That's where you can interact with other people that are using Trino, with people that are developing Trino. If you have questions, if you have pro issues, or if you just want to participate in the project, figure out where you can help. That's the best place to be. We've done about 55 releases, one every 2 weeks. Our target is to release every 1 to 2 weeks, so we've kind of been on target there. And we've made about 8,000 commits since the project split. So that's a total of 23,000. And in fact, the project has accelerated dramatically since the Trino split from PrestoDB. In this chart, you can see the red line is the progression of commits in PrestoDB, and when the split happened, the blue line is Trino. So you can see that the amount of work that started happening at that point increase, and it keeps going. Trino is being used by companies all over the world, across multiple industries. This is just a sample of the companies. You can see some of the big ones like Lyft and LinkedIn and Netflix. There are companies in all sorts of other industries too. And this is just a small set taken from the user's page on the website. So if you want your company to be added, just drop us a note and we can add you to that webpage. Let's talk about some of the features that and improvements that we've made over the past year or so. First of all, let's get the boring ones out of the way. So we revamped security in Trino. Previously, there were a number of endpoints and UIs that weren't secured. So there was no way to prevent or limit access to who could interact with those endpoints. So we big effort to secure those endpoints and tighten security around who can do what and be able to grant permissions around who can do what. Along the way, we fixed this CVE that was reported. So if you're running on an old version of Presto SQL older than 3.3.7 or any of the Presto DB versions, you're using security, you're affected by this issue. So we encourage you to upgrade to a newer version, ideally the latest one. There's always improvements aside from security. And as part of that, we added support for OAuth, both to the UI, to the CLI and JDBC driver. That adds more flexibility if you need to integrate Trino with third-party authentication systems, especially if you're using third-party IDPs in your organization. You can now integrate the whole flow for the UI and for the clients. Let's move on to some of the new language features that we added. There are a number of features in the SQL specification that we've been working towards adding over time. This one in particular is a feature that has been around for a while. We very recently included in Trino. So the idea is, if you're running window functions, in this case, we have average, sum, and max. There's an over clause. Typically, you have to specify the over clause for each of the window function invocations. And if you have many of those functions and you need to use similar window clauses, you end up repeating the definition. So you would need to replicate this window specification in each of these invocations. This is error prone, it's verbose. If you make changes in one, you have to remember to make changes in all of them to make them consistent. So there's this feature called the window clause, which allows you to factor out the definition of the window specifications. And you can assign them a name, and then you can use them in your window functions and share them. It gets a bit more complex. You can actually have window definitions that depend on other window definitions if you want to partially reuse them. If you want to get more details, there's a great blog post that talks about all the different things you can do. Just follow that link. And related to window functions, there's another feature we added. The way, so window functions have a framing scheme, and the SQL specification talks about 3 framing schemes: rows, range, and groups. We used to support just row framing, and in recent versions we added support for range and groups framing. I'm not going to go into details about how those work. Just know that they give you more flexibility in terms of how you can define the frames for those window functions. And if you want to get more details, this blog post also has all the examples. It talks about how the feature works and how you can use it. Right, another big change, there's actually a number of improvements we made around handling of temporal types. One of the big changes is we finally fixed a long-standing issue with the semantics of timestamps in the language. So in SQL, you can think of timestamps as extended dates. It's like think of it as a date that has hours, minutes, seconds, and fractions of second precision. In Presto, for a long time, and since the beginning, this was a mistake we made when interpreting the specification back in 2012, 2013. We actually made timestamps behave as points in time, which is inconsistent with what the specification says. And that caused a number of problems. First of all, it makes timestamps sensitive to session time zone. It makes certain timestamps invalid. For example, if you look at this one, this is a timestamp that falls in the daylight savings transition for US, for one of the time zones in the US. So if you try to parse, older versions, you try to parse this timestamp, it would fail, saying, I can't parse it because that timestamp doesn't exist. So we finally fixed the semantics of timestamps, and now this type of operation succeeds, and it behaves as expected by the SQL spec. And then on the topic of temporal types, we added support for variable precision temporal types. Like this is timestamps, timestamp with time zone, time, and time with time zone. Historically, Presto and Trino used to support millisecond precision only, so that's now a precision of 3 in this between the parentheses. Since we added this feature, now we can have precisions up to 12, which is picoseconds. This is a very important feature for some industries, for example, in financial industry that need to deal with transactional data that has very granular precision, like microseconds or nanoseconds. So you can see in this example, we have a timestamp declared with 12 decimal digits, and that is now properly interpreted as a timestamp with picosecond precision. And then some of the built-in functions, like the ones that provide the current timestamp, current local timestamps, and timestamp with time zone. Now they are parameterized with the precision. This is an optional argument you can pass, and it will give you the value with the appropriate precision you ask for, with proper rounding. Like in this case, 0.66 rounds to 0.7 if you ask for precision 1. Right. There's another set of features we've been improving. There's a whole area around support for correlated queries. This is one of the most noticeable improvements. So now it's possible to have correlated queries that don't refer to any tables. They just refer to a field in the outer query. So in this case, we have a synthetic table has two rows with an array, with one column with an array, and we have a query that scans that table, basically each of those rows, and then for each row performs this entire subquery. So this is something that you can do now. In this case, we are taking all the values from one of the arrays and computing the delta between the maximum value in the array and the average of all the values in the array. And then if it's greater than 1, we output the row. So it's kind of a synthetic example that shows you how you can now refer to a field in the outer query. We added, so Trino supports, or has supported for a long time, the ability to query via select, delete data from a table, and insert into a table. So we recently added support for updates. Now you can write queries that update individual rows in an underlying table. This is, of course, requires support from connectors. There's a set of APIs we added, and we've implemented them for the Hive connector when interacting with org transactional tables. So now you can take advantage of that if you're using that connector. We've also made a number of performance improvements. Like there's lots and lots of small improvements all over the place. Here I'm highlighting some of the most salient ones. The first one is called dynamic filtering and partition pruning. It's a feature that allows Trino to take advantage of data read. Just say you have a join query. You can read data from one side of the query, and based on on the actual data that's read at runtime, it can take advantage of that information to push it to the other side of the join and do additional filtering or pruning. This can reduce latency latency, of course, improve performance of queries that involve joins, especially over partition data, pretty dramatically. This has been around for a few months now, and I mean, you can take advantage of it, especially if you're running the Hive connector or any one of the JDBC-based connectors. We have a new optimized Parquet writer. It's still experimental. It's not turned on by default. So if you are dealing with Parquet data, you might want to try it. Just be aware it's not production ready, but if you run into problems, by all means, file an issue, let us know. I mean, the more people use it, the more people try it out, we're gonna be able to get it to be production ready much faster. And then there's another whole class of optimizations we've been doing over the past couple of years. The idea is to allow connectors to participate in optimization and potentially perform parts of the query on the underlying data sources if the data sources are capable of doing that. We've added the framework to support some of these operations, and then we've been integrating them into various connectors over time. This supports things like aggregations, joins, order by with limit, table sample, and other operations in standard operations in SQL. We have we continuously add new connectors. Like this is actually one of the places where people contributing to the code base have been very, very engaged. And we've added, in particular, over the past year, a couple of very interesting connectors. One for Druid, for Apache Pinot, and for Iceberg. Iceberg and Pinot connectors are under heavy development. They are being used by companies like Netflix and LinkedIn in production. And they're getting, I mean, they are production ready, but they're getting more improvements over time. So feel free to try them out. I put up a couple links here. We had some episodes in the Trino broadcast that went into more details with the authors of those connectors about the capabilities of the connectors, how to use them, and use cases, and so on. We also have connectors for a number of other data sources, MemSQL, BigQuery. Recently, we added ClickHouse. Last year, we added support for Oracle and even for Prometheus. If you're using it to monitor your gather metrics from your systems, now you can integrate Trino with Prometheus, and you can use SQL over those metrics to do more powerful analysis of the metrics. And then finally, there are a number of assorted improvements. Like these are some of the more important ones, I would say. So, for example, if you're running Hive and you're trying to migrate to Trino, or you have a mix of Hive and Trino, you may have views that are defined using Hive dialect. Now, Trino can, so because it's Hive dialect, Trino historically didn't used to understand them and be able to process them. Now with this feature, Trino can take the definition of those views and on the fly translate them into proper Trino SQL queries and be able to execute them transparently. So this brings more flexibility to anyone using Hive and Trino in mixed environments. And it's a production ready feature, but there are some rough edges. So if you're trying that out and you run into problems, let us know. The next feature, this is something that we added sometime last year, is support for org transactional tables. This allows, it brings the power of what you normally think of a traditional database or traditional data warehouse system to the Hive ecosystem. It allows you to delete and modify and insert individual rows into Hive tables, and while preserving the asset transaction semantics. So this is supported for the Hive connector with org data and transactional tables. So of course, this has been integrated with update, so it makes kind of brings the whole power to that feature. Then we kind of on the lower level, we have support for multiple event listeners. These are the type of plugins that allow you to hook into the stream of events about query starting, query finishing. You can get a bunch of details about queries like stats and the shape of the query, the tables that get access, the columns, and so on. So now you can deploy multiple listeners. If you have one listener that's forwarding events to one system and you want to deploy another listener that does something else, now you can have them coexist. Where previously you had to pick and choose which one you wanted to support. And we also have support for multiple password authenticators in a single installation, which allows you to kind of have a hybrid, like if you want to mix LDAP authentication with file-based authentication, you can have them all running at the same time. There are many more changes especially over the past couple of years that we're not going to cover here. We wrote a couple of blog posts at the end of 2019 and 2020. You can follow those links to get all the details. Right, and briefly, let's talk about some of the improvements that some people in the community are working on. These are roughly organized according to how close they are to being landing into Trino. So anything closer to the right is almost ready to go. We've been working on a new feature called Match Recognize. This is something that's being defined since the 2016 revision of the SQL specification, and it's a feature that allows you to write queries that perform pattern matches over sequences of rows. For example, if you're processing stock ticker data, you can look for patterns. You can see, did the stock price go up and down and up and down, and then if that happened, then you emit a row or perform some processing. So it's a super powerful feature, and it's very close to being done. We also have merge, which is kind of a generalization of any operation that mutates data in a SQL database. You can do in a single query. You can do inserts, updates, and deletes. It's one of those power features, and that's in progress. We're expected to land in the next few weeks or so. I mentioned we have the Pinot connector. We have a number of, it's already been used in production by some companies, but we're making a number of improvements, including, for instance, being able to create tables, insert into tables through Trino into Pinot, and being able to push down some more complex operations like aggregations into the Pinot connector to take advantage of the fact that Pinot can process certain operations more efficiently. We have a vertical connector in progress. It's under review now, so hopefully that will land also soon. We're making a number of improvements in performance for Parquet. In particular, we're adding support for this feature called column indexes that allows readers to skip data that is not going to be relevant for the query, and by identifying the data sets early on. So this is in progress now. Again, it's one of those features that has the chance of being a massive improvement in latency and reaction in CPU. There's a project we've been working on for the past year and a half or so around allowing Trino to do dynamic function resolution. This is it's a project that has been going on for a while, but there are multiple steps along the way. Some of them have already happened. Some of them are going to happen over time. So I just put it here as just to make people aware that there are improvements coming up, and eventually that will open up the door to more complex and rich functionality, like, for example, being able to define custom functions in connectors dynamically, or have functions in different languages, like different scripting language like JavaScript, or there's a SQL native programmatic or imperative language to be able to define functions and so on. Last year, we added initial support for materialized views. is very basic and is being integrated with the Iceberg connector. But now we're at the point where we have some people are starting to look into how to extend the system to support more connectors, a richer set of features, and eventually to get to the point where we can take advantage of materialized views for optimizing query execution for any query that can benefit from the materialization. So that's in progress. There's a team of people across a couple of companies working on that. And then finally, there's an effort to add APIs to the connector interfaces to be able to define custom metrics from connectors. So right now, the metrics are hardwired, they're limited. Like, for example, connectors can report number of rows processed, CPU, and so on. With this, it will be possible to expose metrics that are specific to a connector. For example, if the height connector could be talking to S3, so we can track and report the number of requests against S3, so which can be important for someone that's running in a cloud environment. And the same thing for any other connector that maybe might have custom processing of that sort. All right, Brian kind of covered some of this, and I'm not going to go into too many details here. By all means, join Slack. That's the place to be if you want to interact with the community. If you want to get involved with the project, we have a tag on GitHub, so just follow the GitHub repo link. Search for this tag. This is a set of tasks that we consider like entry-level tasks. So if you're just getting familiar with the code base, or you just want to dip your toes, those are good places to start. So just try those out. And then, of course, if you want to write blog posts, we have a community blog. It's open to anyone that wants to submit entries. And then we already talked about some of these resources. So Trino book, if you want to learn everything about Trino, that's a fantastic resource. We have the community broadcast. It's a show run by Manfred and Ryan every couple of weeks, and we cover a range of topics. And like the most recent one was about Iceberg. We also talked about Pinot and so on. You can follow that link. It has all the past episodes. All right, and with that, let's go to questions.
All right. Yeah, let's basically, if you want to take off the share screen, Martine. Yeah, so I kind of wanted to open this up more as like an AMA. So, if you all want to ask Trino specific questions, we have a couple that have come in that I've tracked throughout the presentation. So we can start by asking a couple of those. If you want to ask us anything from like, what have we been up to during the pandemic, or what are, certain things from the early days that you want to kind of know about Martine, Dan, and David, or we also have Eric, who is the fourth member of the original Presto team. If you want to know anything about him, feel free to interrogate him as well. So I already got one new message. Any work to remove Simba ODBC driver and develop an open source ODBC driver? Anybody want to take
awesome. That? Do I hear a volunteer there? Because I think it'd be great if a couple of people could jump in and start building an ODBC driver in the community.
I think Eric saying he wanted to.
Are you going to pay me for it? Sorry. Eventually, I might get annoyed and just do it. Yes, I don't know.
Ping me if you end up getting started on that, Eric. I have some pointers.
Yeah. Please do.
Yeah, that's one of those features that everyone wants, but no one wants to build. So we were looking for volunteers there.
Yeah. Problem is maintaining it afterwards. It's not getting it going. It's maintaining the darn thing.
Totally agree. All right. Well, while we're waiting for more questions to flow in, why don't we go to one of the questions that was asked? I think there was, where is it? Is there any blogs or any kind of resources that we have right now to kind of go into like showing like what pushdowns are supported? And Eric, you were the one that asked this. Is there any specifics like you have? Is this regarding a particular connector or?
Mostly Postgres, because when you're doing geospatial, the geotemporal queries over, I'll tell you, like ships, there's a lot of data in there, lots of data. You need a full push down in those cases, not partial aggregations. So it would be Postgres.
Okay.
And then pushing down to the PostGIS implementations inside of that to be able to hook in the vertical scaling of that system.
Okay.
Not simple sums and aggregations on there, if that makes sense.
Yeah, I don't think we have anything written down, but Manfred, I don't recall, have we added documentation on the Postgres connector about what's supported?
There's an ongoing effort to add more information about the pushdowns we have. So there's top-end pushdown, joint pushdown, and limit pushdown at least. And then there's the aggregate function pushdown. All of that depends on the connector and the implementation of the underlying system and stuff like that. And exactly on the query that's being used and the table stats that are available. As far as I know, we don't have a system that basically says like blindly ignore whatever the query is and push it down. That's kind of what Eric is asking. I'm not aware that we have something like that.
I mean, you couldn't do that because when you type a query into Trino, you're expecting a certain result. So if you have a function that's like, sum of something, it needs to be the sum as you would get if you had run it in Trino itself. So to be able to push something down, you need to have a semantically equivalent function in the target system. Now with Postgres GIS, I think they actually follow the spec pretty well. So that would be actually more likely than some of the other like completely random functions that you see out of systems. It's a challenge because it's like you don't want like you to get one answer and then like the push down to come out a slightly different way because you change the query a little bit and you get a completely different answer. That would be bad.
Regardless, right now it's not possible to push down arbitrary functions. This is something that we're working on. Actually, as we speak, I was talking to someone today that's interested in that functionality, and they're going to be spending some time working on that. So once we have the kind of the infrastructure for doing that, it will be possible to add push down to different connectors and different for different function implementations.
And then some connectors have the ability to like just provide raw queries. Like I know Elasticsearch can. You can just give the raw Elasticsearch statement, and then that becomes your table. But that's kind of a manual process. I know Martine wrote it.
It is. It is manual, and you basically have to provide the Elasticsearch query document encoded in a special way because of limitations around identifier cases, uppercasing and lowercase and all that. So it's not intended for someone to manually use it. It's for tools that generate those kinds of queries.
Yeah, but a 5-second query versus a 5-hour query is pretty important on there. And that's exactly what you happen when you try and pull everything into Trino memory.
Okay.
Yeah. There's not a whole lot that can be said about it. Like there's got to be a matching system and a thing to figure it out and push it down. It's not trivial. I mean, if I were going to do that a lot, I'd probably do a lot of the work in Postgres directly, build a view, and then query that view from Trino. It's just the reality of how it works.
Or a function, right? You could call the view or a function. Yeah, that's a good point on there. Yep.
Cool. I see Mustafa has his hand raised. I'm not sure if he intended to use that functionality. Did you have a question, Mustafa?
Hey, yeah. Nice meeting you, everybody. And thank you for the presentation. Yeah, I was wondering where the name comes from. I realized that I was pronouncing it wrong all the way.
Martine or...
Yeah, so last year when we were thinking about names, we had some candidates, like they were candidate names, they were not going to work out. So when we, like, I think it was the week before Christmas, then if I recall, we had to scramble to come up with a new name, and so we started throwing names around, and the name Neutrino came up, and we said, okay, I mean, that's a nice name, but it's kind of long. It's hard to type. And of course, like, you search for Neutrino and there's millions of different things that have nothing to do with, I mean, it would be hard to come up with an identity for the project with that. So we said, we had the idea of, oh, maybe we can shorten it to Trino. So it was a short name. It was nice. Like, people seemed to like it. The domains were available, the social media accounts were available, so we said, okay, this is the name, and that was it.
Got it.
Good question.
And neutrinos neutrinos because they are fast and lightweight and so on. That's kind of the reasoning.
And if you've ever tried to pick a name for a project, it's super hard because, like, everything you think of is taken.
Yeah, Martine, as usual, made it sound so easy. Just like in code.
Well, the funny thing is that we had been talking about potentially changing the name, and we spent like 2 months trying to come up with names, and nothing really stuck. And then in a matter of a couple hours, we came up with this name. So it actually was easy. But after a long process.
we got lucky. We got
lucky. You got lucky, yeah.
There's a Google Doc somewhere that's got hundreds of horrible names in it. So
what was the food one? There was like tacos, and there was a couple food related ones for sure.
Those are probably all for me. I always think of names when I'm hungry. Like, it should be burrito sequel.
Let's see. We got a question about this is, I think, talking about high availability of coordinators. So supporting multiple coordinators in a cluster. Anybody want to take that one?
So what is the question?
Multiple coordinators in clusters. So I looked at this last year before, I don't know, something like that. I was actually working on it. And I had built some of the stuff, actually someone was checked in, and because it was something that Facebook really needed. And then after we left Facebook, we went around and like talked to, I don't know, 20, 30 like of the big users, talked to everyone, and we're like, okay, what do you want? And they came up with this list, and multiple coordinators would make the list, and then we'd say rank it, and multiple coordinators is always at the bottom of the list. And so I stopped working on it. I started working on the stuff farther up the list. And we're still working on that, like push down, better function stuff.
More connectors always comes up.
Which one?
More connectors for whatever other system.
The number one was like push down, if I remember. Like, that was like everyone needs it to be able to do better integration with traditional SQL databases.
Yeah, and the reality is that in practice, you actually don't need multiple coordinators. The only reason would be if a coordinator becomes a bottleneck. And for typical workloads, it's not. In terms of availability, you can always deploy, you have an active coordinator, and your deployment system can have one ready to go. So if the primary coordinator dies, you can stand up another one pretty quickly. So that tends to be a good enough solution for almost every installation we've seen and everyone we talk to.
Yeah, I mean, to put it in perspective, if your coordinator's dying, like, you have a big problem you need to fix. Like, there's something else going on. Having multiple coordinators is just going to put a very bad Band-Aid on that problem.
Yeah, I think this kind of goes in line too. It's like people have seen different systems before that have had, like just Hadoop in itself. You have the name node and the kind of secondary name node. So people are just very used to this paradigm, and when they don't have it, it's kind of scary, I guess, to think of like having a system out there and not having a backup for everything. I think the same conversation we were having earlier today, and this I think is always good to bring up. We were talking about fault tolerance in the first meetup. Like this is another one of those things that people are concerned about.
Yeah, fault tolerance is the thing that comes up. It's almost like FUD at this point. So we get asked a lot about fault tolerance because for some reason people like to put us in a category with Hive and Spark. But we're not designed like Hive and Spark. We're a traditional MPP database. We're more like a Snowflake, BigQuery, Synapse, Teradata, and so people think that because we can read Hive data that we perform like Hive. They always ask us, what's your shuffle algorithm? And it's like, we don't do shuffles like we do exchanges in an MPP database. So people are commonly asking us like, how do you fault tolerance? And it's like, great, why don't you call up BigQuery and ask them how they do fault tolerance for your query? Like none of these systems actually do it. And like the reality is that we don't typically have a lot of failures in our systems. Like even at Facebook, even when we had systems with actually pretty janky old hardware at times, like we weren't losing machines at a high rate. You don't typically lose machines at a high rate in the cloud, like weeks or months go by, even at very large scale. So at Facebook, we use this number that was like the percentage of wasted compute, which is if I like spend an hour computing a job and that job fails, that's all wasted compute. So we measured that for all the systems, including Hive and Presto. And in Hive, the amount of wasted compute was on the order of like 10%. Because guess what? Hive jobs fail. So you have partial failures, but you actually have total failures because like you have things like the meta store will go down. The name node has some massive hiccup. Like you can't read a file because the replication went to 0 because something wonky happened. Like Hive has all sorts of just the most insane problems. And they actually have a shockingly high failure rate. And everyone thinks like it doesn't fail. Well, the reality is that everyone's using a system like Airflow, which is it's a knockoff of a system that Facebook had written by former Facebook employees that will automatically retry your jobs. And so like, they don't even notice that their jobs are failing. And so we at Facebook went through this process of converting batch jobs. It was something like more than half when we left a couple of years ago. We're running on Presto for a dramatic cost savings. I think it averaged out to like a quarter of the cost of it was before. And our wasted CPU number was less than 1% because Trinos just don't generally fail. So like, again, back to the, like, we're put into this camp with Hive because people can do similar things with Hive. And it's like, we're not at all like Hive. I mean, we purposely designed Presto to not be like Hive because we wanted to avoid all those problems.
Totally. Another question's coming here. Is there any built-in data ingestion in Trino?
So I'm guessing what you mean is things like what Flink or the rest of those things can do. So no. So what typically you run some system that can take your raw event streams and land it in an initial table. And then you can use Trino queries with a scheduled system like Airflow that'll take your raw event data and then eventually convert it to something more managed and organized and queryable. So we're typically part of an ingest flow or can be used in ingest flow. We were certainly used that way at Facebook, but we're not the raw initial event to files step. You want to use something else for that.
Okay, I'm going to ask a question that I asked this morning, and this is going to Eric. Is Eric still on? I haven't heard from him yet. Where's he at? Eric Huang, you there?
I'm right here.
All right. So a lot of folks didn't really know that you had been kind of part of the initial team, and so you kind of did a hiatus for about 2 years, and now you joined back around the time that we moved to Trino. What are you working on now in the Trino community, and what have you been up to these last couple months since you got back in the game?
Well, I've been mostly just flexing my legs a bit, getting used to the entire environment again, because this community has really taken off in the last couple of years, and it's just crazy to see the amount of advancement that has come through. It's like I look at the same piece of code expecting like, oh yeah, I know what this does, and I'll look at it and it's like, hey, actually somebody has gone in and rewrote this multiple times already. So it's quite crazy just how fast everything is moving. In the past, if you guys are interested in, I've done a lot of work with the some of the optimizers and some of the execution engine. If you've seen some of the predicate pushdown, I'm very intimately familiar with that. Done a lot of work with the index joins. But recently, I helped it land some of the performance improvements with some of the top-end rank, top-end row number. If you're using any of those operations, you should see some dramatic speedups on those. And looking forward, I'm going to probably be looking at some of the just ways to simplify the overall deployment of Trino, specifically around how we look at how memory is managed in the system. I put out a GitHub discussion about this a little while back, because I've seen a lot of people complaining about not understanding why certain memory parameters have to be configured, and why and just how to get the basic system running, because those are actually some default parameters. There are some default parameters that have to be set to get your initial cluster set up. So I think cleaning up some bit of that will initially get a lot of the base the base launch experience much faster out of the gate for most people. And just looking at the whole memory configuration system for from Trino, you can actually say that most of it could probably be distilled down into probably almost most of the parameters can be automatically determined to some reasonableness that I think most people would be comfortable with. So that's kind of what we're trying to push that part of that system to.
Nice.
And if you look at most of the comments, that's generally how people end up landing anyways.
Very cool. Very cool. Well, glad that you're back around and you're back getting dangerous again. And we have another question coming in. Let's see. So the first one was with Eric saying, has anybody seen this Lyft repository Presto gateway? It solves multiple coordinator in a different way. Anybody familiar with that on the panel? No?
David,
yeah, so
take that.
We had a similar gateway at Facebook. We actually worked with the Lyft guys pretty closely, and we had like a whiteboard session at their office when they're in like the middle of designing this thing. There's several companies have their own gateway like that. A lot of them end up being like, it's specific to what you want to do. Like the Lyft one works a certain way. The Facebook one worked somewhat similar, but somewhat different. And then we've seen like other designs as well. It just really depends on what you want to do. But that is a common way to solve the problem of like, I've got multiple clusters and I want to like route traffic between them, is you put something in front of it.
Very cool. Very cool. Let's see. So got another one that came in a little while ago asking what are the, and actually this kind of probably goes to you as well, David, what are the possibility and limitations of Iceberg as well as Hootie tables in Trino?
So I'm not very familiar with like Hootie. We're very excited about Iceberg. Like Iceberg has a strong community, has lots of big companies using it and like actually like working on it to improve it for like real world use cases. It has a strong specification. Unlike Hive, which like where Hive is just like conventions and there's a whole lot of different ways to do stuff, and like everyone's all trying to like work on the metadata in the same way and like hope it works out, whereas Iceberg like actually has a spec and everything like should follow the spec. And then for users, like Iceberg has a ton of nice features like atomicity, hidden partitioning. Like Iceberg's great. Like we recommend everybody check it out. And if you're starting from scratch, or you're looking at like, how should I be storing my data? Like Iceberg would be my recommendation.
Awesome. Right. Let's see. Another one up here. I want to make sure we're not missing any of these. Any experiences with Trino on streaming data? So this is like Kafka and Spark. So this is, I guess, asking about, are we able to query, Kafka? Are we able to query stream? How does it work to do a batch system over over Kafka? And I think Martine had kind of mentioned something around this before. Is kind of like what this question asker is looking for. Kind of getting confused between how Trino is actually going to be pulling this versus a long living query or something like that. You wanna touch on that a little bit more, Martine?
Yeah, when people talk about queries over streaming data, there are two ways to see that. One is the idea where you're running a query, a long-lived query over a continuous stream of data, and that query can produce, for example, you may be generating every hour a count of the number of events you've been seeing, and this is on real-time hours, not hours based on some field in the data. So that requires a different type of system. It requires a system that can where a single query effectively forms a processing pipeline, and it's active continuously. It can recover from things going down, or for example, if you upgrade the system, you have to be able to shut it down, save the state, restart, and continue. Trino is not the right system for that. There are systems like Kafka, I think it's Confluence, KSQL, it can do it. Flink, I think, can do that kind of processing. However, what you can do with Trino is you can plug it into data sources that are effectively the Kafka streams or the Kinesis streams and so on. So you can query the current state of those streams and apply all the SQL features from Trino, but you can't have a query that is one of those never-ending queries that just processes for a long time.
Okay. We have two more questions. I think then we're out of time. So Rohini asks, what's the deal with Trino Starburst and their recently announced Presto conformance program? How will that work moving forward?
So there are, we started some discussions with the Presto DB. Starburst started some discussions with the Presto DB project. We'll see where that goes. The idea is to kind of come up with some program where we can define what does it mean to be compatible with Presto, so people can say their product is compatible with that technology. So I think it's very early in the discussions, and that will be driven primarily by the Presto project. So right now, I don't think there's anything much to report there.
Gotcha. And then can workers talk to each other using HTTP 2.0? Is there any performance gain possible if we use that version?
I was hoping David was going to answer that. There is a flag, you can turn it on. We did some initial testing and ran into some problems and just haven't gotten around to have the time to actually work them out. We ran we have a pretty big benchmark suite and just ran into some issues. It could be something as simple as there's a lot of tuning options already in, but those tuning options are for HTTP 1, not for HTTP 2. So it could be we're just tuning it to the point where it breaks for HTTP 2, it's just not clear. So it's just a bunch of work to figure out. And if once we do have HTTP 2, there's some I don't know how much it'll help in terms of performance, but it allows us to make some architectural changes. Because HTTP1's connection oriented, so you have to be cognizant of how many outstanding requests you have, because an outstanding request consumes a connection while it's in flight. So with HTTP2, you can you have multiplex connections, so you can you don't have to really take that into account anymore. So you can have a lot more in-flight requests, which means you can just design certain things differently, which can simplify and improve things. As always, like the biggest performance advantages are wins are always like change the architecture, not like tweak some little thing.
Okay, I know we're just past the top of the hour. I want to try to squeeze the one last question that came in, which is any plans to support Redis clusters? And then that is the last question we can answer.
Redis is that clusters? Someone volunteering to do a Redis connector? Is that what I heard?
So we have a Redis connector today. I don't know if it works with Redis cluster, if that's the question.
Apparently it doesn't work. I'm not familiar with the Redis connector myself, but I don't know if it works for clusters. I guess that's a different mode or something.
I'm guessing what they're asking for is something similar to how the Elasticsearch connector can basically be aware of what the Elasticsearch cluster is and then parallelize the requests out to multiple nodes. Maybe Redis has a similar feature.
Sounds awesome. We're an open source project, so
I was just gonna say, look at the Elasticsearch connector as an example and send a pull request.
Yeah. And if you can't follow any of the other, if you're trying to crib off connector, don't understand what it's doing, jump on Slack and ask. There's tons of people who can answer.
Cool. Well, that's a good way to finish it up. Please join us and do development with us and document things with us. That's always our call to action at the end of these. So thank you everybody for attending. We're really excited about these. Next month we're going to have Ryan Blue, the creator of Iceberg, joining us to give a little bit of talk about Iceberg and some. We started in the Trino Community broadcast doing a couple use case dives with him and talking about all the different ways he's seen Iceberg being used. So he's going to jump into a lot more of those because that was just super fun to listen to all the stuff he's seen in the wild, as well as just kind of introducing Iceberg. And then we're also going to kind of relate how Trino uses it as well. So look forward to that coming up in May. We'll nail the dates down here in a little bit and look forward to the invite and look forward to seeing you all in 1 month's time. So thanks everyone. See you all.